Hello, good evening. I'm Cheryl Ilg with the Friends of the Homer Public Library, and I would like to welcome you here to the Homer Public Library's Fireplace Reading Lounge for an author talk and slide presentation with local author Naomi Klouda. Naomi Klouda, a longtime Alaskan journalist, wrote for several newspapers, including the Anchorage Times, the Kodiak Daily Mirror, the Anchorage Chronicle, the Tundra Drums, the Valley Frontiersman, the Alaska Journal of Commerce, and finally, the Anchorage Daily News, where she retired in 2018. She is the author of Anna's Whale, a novella set in Village, Alaska, during this time of climate change when a rare whale beaches on the shore. She is the author of the newly released Alaska Glacier Dictionary, which you're going to hear more about tonight, a compendium of 700 named glaciers plus essays and definitions. The subject of her talk tonight is Every Glacier is Different, a nod to the uniqueness of each sacred behemoth we know as our backyard neighbors. This presentation is being recorded and filmed by Brian Smith for Alaska Book Week to take place in October later this year. We also have here in the back Emily from the Homer Bookstore with copies of Naomi's book for sale, as well as titles authored by Jim Levarkas and Brian Smith. And there will be an opportunity at the end of this talk for you to have books personally signed by the authors. And without further ado, please help me welcome Naomi Klouda.
Hello, it's wonderful to be here tonight. It's a great turnout, even though it's a sunny afternoon, evening here in Homer. I'd like to introduce my co-conspirators here. Brian Smith, back on the camera. He's a Homer-based writer. His memoir, Golden Boy, The Rock and Roll Diary of My Life, is available, as are two books of Ida Mae Joy, Alaskan Adventure series, Gold Dust Dreams and Pearl in Search of Ida Mae. Jim Levarkas, who took the photographs. So Brian did the design of the dictionary. And I guess you kept somebody out of the blue, and he rose to the challenge to design this dictionary. It's 700 different entries of glaciers and a lot of moving parts with a ton. We have more than 200 photographs in the book as well. So no small thing for Brian to have been the designer. And I brought him along tonight so that he could answer some questions if you should have any from that angle. Photographer Jim Levarkas is also with us. His childhood home is in Massachusetts, and he moved to Alaska in 1975, fresh out of college with a BA in English. He was bouncing from job to job for the first 5 years, and then he began a freelance photography business specializing in performing arts in Anchorage in 1970s, and got noticed by the city's two newspapers. So his career was at the Anchorage Daily News, and he has built a sideline on glacier photography. So he has some interesting stories about how he was able to get some of the photographs that we have in the book, in the Alaska Glacier Dictionary. So that's our introductions, and now I'll go ahead and just start with the actual slideshow. Gruing Glacier is a stunning glacier located in Ketchikan Bay State Park here near Homer. It stretches over 13 miles in what is one of 6 glaciers forming the Gruing-Yaluk icefield. Yaluk is on the other side of the mountains from Gruing. The glacier lost 700 vertical feet between 1952 and 2015. A landslide in 1967 triggered a tsunami when a massive chunk of mountain, 110 cubic yards of rock and debris, crashed into Gruing Lake. It swept down and carried trees into Ketchikan Bay. Gruing is receding rapidly. This photo shows Carly Dixon of Tutka Bay wading in glacial waters. It was selected after much debate for the cover of the Alaska Glacier Dictionary. The terminus of the glacier shows the receding power of global warming. Each year the toe sees more calving, expanding the lake. This is one of the most accessible glaciers in Alaska at the end of a walking trail. From the beachside entrance on Ketchikan Bay. The lake is 400 feet thick, deep in parts. Jim, did you want to mention something about how you did the photography for this one? It's unusual to see somebody just wading in there with all of the eyes.
So I worked at the Tucka Bay Lodge for a few years, and Carly needed a ride across to Gruig, so I took her along, and I had my camera with me, and I was taking pictures of people down at the water edge there, and she pulled off her top and went wading in the. She had a bikini, she had a bathing suit on and waded in there. So being being a journalist, I was ready for kind of an unusual thing to happen, and it did. And so I get this picture of her coming out of the water with some ice. But can we go back for just a second? I want to say this is my favorite picture of Gruig Glacier. It's moody. It's got great light in it. And the thing I wanted to say about the opportunity to take pictures of glaciers is that if you can see it from your deck, you have a great opportunity of taking pictures over time and seeing the personality of the glacier come out. And this is from the deck of my home. You can see the roof of my neighbor here across the street. And so I go out and I see something going on with light at the glacier, and I take pictures over time, and you can see and you get to see the personality of the glacier. And that's just saying it. If you have the opportunity at your homes to do this and just make it a special project, this is how you get great pictures over time.
Yeah, it's no small thing to be able to take photographs of glaciers. There are lots of them out there, but capturing the character of the glacier is what's really interesting. Also, another aspect was seeing how people interact with glaciers. These glaciers aren't just off in our backyard on their own. They're being interacted with. So I was particularly interested in finding glaciers that had that human interaction. So that was part of why I chose the cover. Now, the Gruig Ice Complex is a glacial system located in the Kenai Peninsula of south central Alaska. It's considered distinct from the Harding Ice Field, which feeds about 40 outlet glaciers in the region. This is going to start showing you just how many glaciers we have in our Homer area. The Gruig Yalik includes Dixon, Portlock, Wosnesensky, and Dinglescat glaciers in our regions. These glaciers have historically advanced and retreated in tandem during the Little Ice Age and in earlier periods. So we have all of these in addition to the Harding Ice Field not far away. We're truly inundated by glaciers in this area. Now we're going to switch to up north, Ruth Glacier at Denali National Park. It shows a different kind of a glacier. Again, the topic here is every glacier is different. And Glacier shows a long and complicated history with various moves. Over time, it helped shape one of the more interesting gorges in North America. It's named after Ruth Hunt, the stepdaughter of Frederick Cook, and one of only about 10 glaciers named for women in Alaska. She was a child of 8 when Cook designated the name. Perhaps it seemed like a star in the galaxy was her namesake, so remote the honor. So these are also photographs by Jim Lavacras here. It's approximately 40 miles long. It features the stunning Great Gorge, which is about 1 mile wide and drops nearly 2,000 feet. Like many glaciers in Alaska, Ruth is experiencing significant melting due to climate change. Scientists have been studying the ice thickness and retreat patterns using ground-penetrating radar and satellite imagery. Now, not all glaciers have been measured for their depth. Gruig, I was asked, how deep is Gruig Glacier? And my understanding from one of the glaciologist experts that I consulted was it's between 300 and 900 feet thick. So it hasn't actually been measured using ground-penetrating radar, but there are estimates for that one. Ruth Glacier's Great Gorge is often compared to the Grand Canyon because of its depth and dramatic vertical walls. In fact, the Great Gorge is deeper than the Grand Canyon, measuring nearly 9,000 feet. Unlike the Grand Canyon, which is wider than it is deep, Ruth Gorge is narrower but plunges steeply, creating a towering granite-walled corridor that is only about a mile wide. The glacier itself is 3,770 feet thick, filling the bottom of the gorge. So you can kind of imagine the depth there. Now I'm going to talk to you a little bit about Austin Post. He was another photographer who ended up in the Glacier book. He was busy with the USGS from the 1950s until the 1970s. So he had a nice long career there. He took black and white photographs by mounting cameras on his airplane. So there were cameras mounted on the wings of the airplane and then on the nose. And he got these incredible otherworldly shots. So this is one, Agassiz Glacier from the 1960s. It shows, because of the distinctive patterns, again, no two glaciers are alike. This Glacier Cirque, for example, is 15 miles long, and it's near Malaspina in the St. Elias Mountains. It's named for Louis Agassiz, a Swiss-born American biologist and geologist who is recognized as a scholar of Earth's natural history. So you'll start to see the reason why we have names. How did certain glaciers get names? Well, that comes into the Glacier Dictionary because, the nomenclature of them is fascinating, and it links to specific parts of history. It links to specific historical figures. Very worth mentioning and taking note of. Now, Antler Glacier, it became extinct during the time that I was writing this. I had it all listed. I had whatever the facts I could find on Antler Glacier, and then in 2024 it was announced that that glacier has disappeared. So just in this small frame of time, already, we see glaciers disappearing. Global warming is something very real and significant. The biggest glacier in Alaska is Bering Glacier. And I loved this shot. This is by Chris Larson. He's with the U.S. Geophysical Institute in Fairbanks. So he was out photographing, on the ground for this particular glacier. It's the biggest glacier in Alaska at 19,000 square miles when combined with the Bagley ice field. The glacier itself is 1,700 square miles. It's so big that the glacial retreat has an unfortunate side effect of earthquakes in the region. The collision of the Pacific and the North American tectonic plates created the Wrangell and the St. Elias Mountains, and the weight is enough to push down on the Earth's crust. But as global warming becomes more apparent, the melting and the weight of these glaciers is not quite as significant, and we're seeing more earthquakes because of that. Of climate change. Now, most of these quakes are triggering low to moderate quakes, so they're not enormous, and we don't feel them in Homer. People in Anchorage don't feel them, but they're very much felt in that region. Okay, so Bear Glacier is a little closer here to Homer. It's 21 miles long. This one's another example of a glacier that's receded dramatically in this century. Bear Glacier is located in the Kenai Fjords National Park. It reached its little ice age maximum position in 1888 and has since retreated about 4 miles, with most of that loss occurring after 1950. In recent years, Bear Glacier's retreat has accelerated dramatically. Between 2005 and 2019, its average annual retreat rate nearly doubled, reaching 554 feet per year. Now we'll move over to Glacier Bay National Park. Brady Glacier is an interesting glacier because it used to be a calving tidewater glacier, meaning it actively dumped ice into Taylor Bay. But over the next century, the glacier advanced 8 kilometers and it transitioned to a tidal glacier, from a tidal glacier to a non-tidal one. But unlike many glaciers in the region that have retreated, Brady Glacier has managed to preserve itself due to the large outwash plain at its terminus. So not all glaciers are equal either in terms of their retreat rates, or we're seeing a lot of diversity in these glaciers. We have some that are advancing. We have some glaciers that are growing. Now, another thing to note about this particular glacier is it was named for Governor John Green Brady, who served from 1897 to 1906. And again, you have glaciers named after governors, you have glaciers named after politicians, you get glaciers named after Indian chiefs. So there is a lot of diversity in the names themselves. Here's another one of those photographs by Austin Post, taken from the air with those cameras on the outside of the aircraft. It's just elegant. And it shows Brady Glacier with Brady Icefield, a very significant glacier. Now, Columbia Glacier is one of the superstar glaciers, of course. People go out on cruises and pay huge amounts of money to see Columbia Glacier calve. And it's a pretty remarkable one. This particular photograph was taken in 2022. Now, the glacier covers 400 square miles and it's up to 1,800 feet thick. But take note of the seracs. It stretches 32 miles from the Chugach Mountains to the sea. And since 1982, it's been in catastrophic retreat, not just retreat, but catastrophic retreat, losing 13 million tons of ice daily. So when you want to talk about global warming, this one is proof extraordinaire. Now, it was named for Columbia University. It was named during the Harriman expedition in 1899. Now let's take a look back. Again, another photo by Austin Post. This is from 1961. Columbia Glacier isn't as distressed looking. It doesn't have as well developed seracs. These are common on fast-moving glaciers, but even healthy cold glaciers can have them simply because of intense ice movement. However, heavy melting can accelerate their formation. When ice thins, it fractures more easily due to the warming. Seracs can become unstable, breaking apart faster. Okay, now we're skipping ahead to 1973, and you begin to see how that glacier, it's a different camera angle, but it still shows that something's been on the move with this particular glacier. And now we have one from 2023, and you can see how the seracs are extremely distressed. So it's kind of showing, just how much melting is going on that glacier. Triumvirate Glacier is a stunning glacier located in the Matanuska-Susitna Borough. It stretches about 14 miles in length and starts at an elevation of 2,303 feet. This glacier is known for its breathtaking ice formations and is often visited on flight tours alongside Mount Spur, the active volcano that last erupted in 1992. Triumvirate refers to the three mountain peaks that look over the glacier. Now you notice that there's no seracs on this one that we can see at this particular angle. Very, very different looking glacier. Gdaskany Glacier is of native, Dena'ina native origin, meaning the one that is burning inside. And this glacier heads on the southeast slope of the volcano Mount Spur and flows southeast towards the Chakachatna River, 34 miles northwest of Tyonek. It's one of 15 glaciers on Mount Spur. So a lot of people don't realize we have a combination of glaciers and volcanoes going on in Alaska. Spur has 15 glaciers, Iliamna has 10. We have Mount Redoubt with its Drift River Glacier, which you'll see here in a moment. So here's the lineup of the glaciers. Triumvirate is just one glacier located near Mount Spur. Redoubt has the famed Drift Glacier on its peak. Eruptions in 1966, 1989, 1990, and 2009 severely impacted Drift Glacier. They actually use the word it decapitates. These volcanic eruptions decapitate the glacier. But nevertheless, somehow, after the last eruption, it has recovered. It's 5 to 6 miles in length. And this particular photo I didn't get to use in the book because the author was just getting ready to publish this report. It was a new study, just that it didn't make it into print before my book did, so I wasn't able to use this photograph for the book, but I was able to use it for this. Drift Glacier has, you can see how here's a canyon down here, and here's the glacier, here's the volcanic hole. And what's happening here is that after the eruption ended, normal snowfall led to the eventual regrowth of the glacier. So even though it was severely disrupted, it's been able to grow back. And that was the significance of this particular study that I didn't get to print in my book because it was so new. Again, we have pictures of people interacting with glaciers. Glaciers aren't just out there in the unknown. I mean, people have been fishing alongside them. People have been interacting with glaciers for hundreds of years. And I like this one by Jim Levakris of Billings Glacier for that purpose. It shows the interaction. Now, this glacier was named in 1908 by Grant and Higgins of the U.S. Geological Survey in honor of Commodore Joseph Billings, who led a Russian exploring and surveying expedition in the Bering Sea and North Pacific Ocean after Bering came through. So his year was 1791, 1792. Another example of how old some of these names are and how they honor significant areas of history. Whether we like those significant areas of history honored or not would be up to your personal preference. Like I say, only 10 glaciers are named after women. And there are certain native names on glaciers as well, but they were covered over with colonial names. So, all part of our history. Now here's Gabriel Icefall. One of the sources for my book also was photographers, that had been out in the field. They had been, over time, photographing these glaciers and noticing their movements. Sometimes they're the only people that you can call on. They're so remote, these glaciers. This one's attached to the Golcana Glacier. And Lee Peterson was the one who wrote me nice long emails explaining, how he had been out there for 5 years to carefully document its changes. And he said its rapid melting or altering formations give it a different look every year. I don't know if that slide comes across as well as I'd like it to. Okay, Herbert Glacier is down by Juneau. It's named for Hilary Abner Herbert, a lawyer and a U.S. naval colonel who served in the Confederate Army during the Civil War. We don't know if he ever came to Alaska. We don't know how his name ended up on a glacier. But this particular glacier is interesting because it's advanced atop a forest sometime in the Little Ice Age, between 1500 and 250 years ago. The river is now exhuming the stumps of a fossil forest, and it's accessible via a trail. So we've got glaciers that have stomped over salmon streams, they've stomped over forests, and they're very interesting for glaciologists to study because you can go back and you can carbon date, from a certain time, which is how we have here, the Yalik ice complex we know that one is distinct from Harding ice field because of the tree dating that has happened. And we know there's certain parameters, and so. Now, Klouda Glacier is a significant glacier for a big part of Alaska's population there in Anchorage. I mean, it's the source of the drinking water, it's the source of their electricity. They have a hydro project coming off of Klouda. Klouda is predicted to be gone by the year 2100. So already the city of Anchorage is looking at, okay, so what can we do to find an alternative water source? Now, glacier tourism has been a thing in Alaska. It's not new, it's not a new invention. People came to Alaska for glacier tourism back in the 1880s. It was highly popularized by John Muir and his writings and his collaborators or his colleagues. This photo was taken during Victorian journalist Eliza Skidmore's Alaska trip. Glacier tourism had taken off thanks to John Muir and others who were sending back information about the magnificent glaciers. She was a writer for National Geographic and its first woman author who went on to write several books on her travels. An essay of hers is featured in the Alaska Glacier Dictionary. And she's fascinating because, again, one of those 10 women that we have named, have a glacier named after them. She's one of them, Skidmore Glacier. They actually brought their picnic baskets and, made a day out of it with their glacier. Just this worship of glaciers almost. Now, Knik Glacier is another one that I think is highly unique and it's interesting to talk about. It was the setting for the Star Trek VI movie, The Undiscovered Country, in 1991. And in the movie, the glacier served as the icy landscape of Rura-Penth, the Klingon penal asteroid where Captain Kirk and Dr. McCoy were imprisoned before their escape. Knik is about 25 miles long and 5 miles wide. The word Knik is believed to be derived from an Inupiaq term, ignik, for fire or blaze, and it possibly references the area's history of wildfires or volcanic activity. Now that's one picture of Knik. Here's another one. Again, we're not seeing those seracs that we saw on Columbia Glacier. We're not seeing a smooth surface like we do on other certain glaciers. This one is distinct in the way that it has been creasing and folding and moving. It's about 5 miles wide, and it's about 20 miles long. So. Now the Knife Creek glaciers are another must-mention collection of glaciers. These are over in Katmai. Now, what happens when, after the 1912 Nova eruptive volcano, it stacked 6 feet of ash onto the volcano. It just went all over. It's still there, so you can go visit these glaciers. You can see them, but they're chocolate covered with the ash. With ash, sometimes it can preserve the ice, sometimes it can accelerate melting. So the answer there is it just kind of depends. But we have two things going on with those glaciers. They are listed as endangered. Now, Buzz Aldrin, Neil Armstrong, and Michael Collins from the Apollo mission spent time in geology training there in 1965, 1966, somewhere in there. And Alaska glaciers aided their famed lunar landing in 1969. But they also trained in the Grand Canyon. So here they were trying to find a surface on Earth that was so unique and different that it would somehow be comparable to the moon. And they came up with the Knife Creek glaciers in Katmai. So here we are still at the Valley of 10,000 Smokes, showing the ash-covered ice. Unlike many glaciers that are retreating, the Knife Creek glaciers have remained relatively stable due to their insulating ash layer, which slows melting. But some glaciers in the area, like Fourth Glacier, have remained stationary since the eruption, and it's experiencing some exceptions now. They're considered endangered due to global warming. They were included on a list of 200 glaciers likely to be gone by the year 2100, according to a study of the Geophysical Institute of UAF in 2024. That list was quite significant. There were 200 glaciers on it. So as I went through the glacier dictionary writing this book, I was writing, this glacier is rapidly receding. And I was writing it over and over again after explaining the vital statistics on those particular glaciers. Very disheartening to have to write that over and over again. But again, there were some exceptions. Now the poet glaciers, I thought they were interesting. Again, in the history of nomenclature, they decided to name some of the glaciers after poets. So we have Shakespeare, we have Greenleaf Whittier, we have Lord Byron, we have Robert Burns, who did Old Lang Syne, the New Year's Eve poem and song, and we have James Russell Lowell. So here's a humble Shakespeare, a retreating valley glacier, like Byron and Burns and nearby Portage Glacier. It's greatly reduced over the past 40 years. So if you want to picture what was going on in Turnagain Arm, you know, we can kind of look at Portage Glacier and piece together that glacier did extend out into Turnagain Arm at some point. It's another extreme example of global melting and warming. I think Jim brought a photograph tonight of Portage Glacier that shows when it was up against the parking lot. You could just go park there at Portage Glacier, and there were the icebergs and there was the glacier. Not anymore. Now you have to take a boat back there to see it. So it's a historically significant byway. Again, people were using glaciers. They used them for a walking trail. They used them as a path to get over to Seward. There was a lot of interaction with the Valdez Glacier during the gold rush, where you had hundreds of, even thousands of people making their way across those glaciers to get out to the Copper River area. So glaciers are something that people have been interacting with for a long time. And it's interesting to me that we continue to interact with them, but we also let them be out of sight, out of mind. And maybe we need to think about glaciers a little more closely as tied to us. Here's a slide of Alaska's Ice Age glaciation about 115,000 to 11,700 years ago. It shows just how many glaciers there were in Alaska. And notice where you live in this particular drawing. It was extremely heavily glaciated. Today, these are where the glaciers are. So on the North Slope, we don't have that many of them. Think about the Bering Land Bridge there. Can you see how there's the two areas of landmass between east and west there? And there was the Bering Land Bridge. That was how people were allowed to come into North America, was because the glaciers weren't there. The glaciers were scattered a little bit on the North Slope. You can see some out in western Alaska, a lot along the Aleutian Chain, a lot in the Denali Park area, a lot over on the Canadian side, the Klondike, where the gold rush was. Of course, there were a lot of glaciers to deal with. Today, these are the names of the national parks. So we've got the gateway to the, we've got up north this area in gateway to the north, to the, what is it called? Gates of the Arctic, right. You have some glaciers up there, but not a whole lot. They are still finding glaciers, and they're still naming them. So, and that's happening on the North Slope. We have the Denali area there in the middle. We've got Lake Clark over here to the side, Katmai. You can see where all the glaciers are. Look at where we live. Look at how many glaciers are still down on the Kenai Peninsula. So we're people of the glaciers. we remain that. Okay, and now I'd like to open it to questions if you have any for Jim or Brian or I about how the book went, or whatever you might want to ask about glaciers. I'll do my best to answer. I'm not an expert on glaciers, but I feel like I had to really learn a lot in order to do this book. Yes.
You introduced the term, I don't know if I'm saying it correctly, Seracs, when you were talking about the Columbia Glacier. Could you tell us, give a definition for what that is, and how is it formed, and where is it?
Right, a definition for Seracs is, so it's a French word, and it's, picture the cheese wedges. There's a Serac of cheese wedges. That when the first explorers came to Alaska, they were seeing those wedges, and this became the term that was attached to them. But yeah, they're, whenever you see the triangular formations of a glacier, that's a serac. It's, and there's different kinds of them. They take several different kinds of forms. But they're interesting because they can really tell you, they can tell glaciologists where that glacier is at. They're a real good visual for determining, how distressed is the glacier? Is it close to, it's melting? Is it holding up? I mean, there's some seracs that are solid as rock and mountainous looking. So they're a good tool.
Naomi, what possessed you to take on this particular project? I know you've been writing for many years, and
Right.
I didn't think of you as a glaciologist.
Yeah, I was busy in my own little world there, looking at glaciers for a number of years. It might seem like an improbable topic for me because as a newspaper writer, I had to cover, murders and business and government and politics and so on. But I would still notice something when I was flying over Alaska. I would notice the glaciers. I would notice, well, how big is that one, and is it melting, and what's going on with that? And there would be holes, like when I worked up in the Yukon-Kuskokwim Delta. You wouldn't see glaciers in that part of Alaska very much. Again, it's western Alaska, so you don't have a whole lot of glaciers. But I would see the potholes, like indentations in the earth, and I would wonder, well, was that where a glacier was? And the answer is no, but it had to do with, global warming. So yeah, between global warming and glaciers, I just was fascinated, and I just kept reading and kept digging. So it became something that I dearly loved to ponder. Yeah.
Can you speak to the glaciation of Ketchmak Bay itself?
Right, there's some really interesting studies going on with glaciers in Ketchmak Bay. There's a salinity study that's coming out of, I wish I had that particular reference with me, but yeah, there's, Ketchmak Bay was of course shaped by glaciers, and we have, they continue to shape Ketchmak Bay and impact the reason why we have such fertile waters, the reason why there's such good shellfish, such good habitat for sea otters and so on, is because of the glaciers, glacial nutrients that have been shedding down into the watershed. Very, very fascinating place for glaciers. We have Ed Berg here tonight too, who, I don't know if he wants to say something about Ketchmak Bay and its being shaped by glaciers.
I recall taking a group of school kids over to Klouda Glacier. Probably many of you have done this as well. One little guy pops up with the question, and he says, well, how old is the glacier? Well, I really was not too sure how to answer that question. So, prompted some inquiry. And I talked to Chris Larson, who you mentioned. He's a glaciologist at the Geophysical Institute that has flown the aerial surveys repeatedly over the Harding ice field and the Klouda complex, to measure the changes, the shrinkage, and so forth. So, in terms of the ice, if you pick up a piece of ice floating in the lake, that beautiful clear ice, the general thing is that that ice is about 100 years old. That about 100 years ago, it was first, snow falling up on top, and then that becomes compressed as firm, very coarsely crystalline snow, and then that becomes ice proper, and the ice flows down, to the lake. And it takes about 100 years for that snow, to get down into the bay and be there as ice. So that's kind of the short answer. In terms of the ice that you're looking at now, okay, 100 years, but how long has the glacier itself been there? That's a much longer question. And we know that glaciers were starting to form in the late Pliocene period, let's say about 3 million years ago, and then the Pleistocene ice age starts about 2.6 million years ago.
Right.
So, generally, the area has been glaciated, but the glaciers, of course, have advanced and retreated. My current thinking on this is that much of the Ketchmak Basin itself was formed by a river, similar to the Kenai River and the Tuscaloosa, the Seal River, all of these rivers coming down. And those rivers flowed into the ancestral Cook River that flowed for the last 65 million years down the Cook Inlet Basin. So the initial formation of what we call Ketchmak Bay today was this river system with these rivers coming out of the mountains and so forth. But then in the Pleistocene ice age got going, these valleys are filling up with ice. And the climax of the last glaciation, the ice filled up to the top of Skyline Drive and so forth. And then that glacier extended out and joined the main ice stream coming down the Cook Basin, and it bent around and went as far north as the Anchor River. And that, when it melted, it left a trail of moraine there along the old Sterling Highway with all the lake basins. But that's only the last major advance. And we know of two major advances, but they're probably earlier ones in the early Pleistocene. But each glacier tends to destroy the evidence of the previous glacier, so it gets hard to complete track record.
Right, in one of the tours that I took on a glacier, the tour guide told us, to go. He used a chop axe, some kind of a hand axe, and opened up a meltwater stream so that we could, put our cup underneath there and fill it up with glacial water. And he was saying that glacial water was about 700 years old. So different parts of ice are different ages, depending on where we're at. So it's very hard to date a glacier. Any other questions? Thank you.
If you look at a chart where Ketchmak Bay meets Cook Inlet, there's a ridge, which is where people halibut fish. Is that the remnants of a terminal moraine?
I don't know that, but we do have. Isn't it the Homer Spit a terminal moraine? We're surrounded by them, so I wouldn't be surprised.
Well, the Homer Spit, there's maybe two mechanisms or two theories involved in that. One is that it was a
Sir,
certain
can we use a
marine.
speaker, because it's really hard to hear. If you'd like-
Here, Ed, would you like to come up here?
So regarding the Homer spit, probably two mechanisms involved there. One is that it was a tidewater, submarine glacier like you'd see in Prince William Sound today, with the big ice front, ice calves off, and then the debris that the glacier is bringing down, dropping into the water and forming this underwater moraine. So probably the base of the spit was formed that way. But since the ice, and that was relatively recent, I mean, that's like 16,000 years ago. But since that time, we have longshore currents, coming down, bringing sand and gravel onto the spit. So the spit is constantly, being reinforced. And a lot of that gravel gets deposited out in front of the spit, that long shelf that runs out the Archimedes shoals, to the west of the spit. Now, there's a deep trough cut into the floor of the Ketchikan Basin that's about 100 fathoms, and between the spit and Yukon Island, and that probably formed very late in the basin by the advance, the bigger advance that I spoke about earlier that filled up the whole bay, cut the floor in the ancestral Cook River Basin there, cut that groove there that runs out. But the general floor of the basin is something on the order of, 30 meters or 100 feet or something like that. And much of the basin is that, and you can see that in the modern bathymetry that was done in 2015. Within, in that broad floor is cut this big slot, groove that runs out into Cook Inlet. And I think the particular ridge that you're thinking of is probably part of that ancestral floor, probably bedrock, and just something that survived the glacial grinding.
Thank you, Ed. It's wonderful to have you. And we have Janet Klein here too tonight, so if we had any questions for her. Did anyone want to ask any questions about photography? We have Jim here, and he could give you some pointers about, if you're curious about taking good glacier photos or, capturing, these are historical documents that we're capturing in taking these photographs. Would you like to address how you...
Just a few things.
Sure.
As you can see, a number of the pictures that Naomi chose that were mine were shot from an airplane. In particular, the Ruth Glacier was a trip to the glacier itself to deposit my mother-in-law's ashes. That she grew up in Alaska and she wanted her ashes put on the glacier. So we hired K2 in Talkeetna and flew out, and I was taking pictures along the way. And one of the things, of course, that that is a problem in an airplane is you're shooting through pretty thick plexiglass. So you have to be, at a right angle to the window. You have to remember to keep your horizon straight, because you always end up with, it looks like you're going to fall off of the picture. And you have to keep from getting sick. So when I worked for the newspaper, I did a lot of flying in the state. I did odd stuff, and then just flying to get to places. And I always used scopoline. I learned very quickly that trying to take pictures, trying to sustain picture taking for 15, 20 minutes at a time was not possible without some kind of assistance medically, medicinally to do that. The other thing that I wanted to point out with glaciers and reflective things that reflect a lot of light is that your light meter can get thrown off. And you just need to, in the day of film, we prayed that we got a decent exposure and that we didn't underexpose something because it was so bright. And we were cranking the aperture down to deal with the light. But with digital, you can of course look at right away and see, okay, it needs to lighten up or it needs to darken. So that's an issue with shooting. Glaciers on a bright day can really throw off your light meter. And just as an aside, we used to call this chimping. We because a chimp could, you can see somebody looking at their images right away and checking their image. We call that because a chimpanzee can shoot great pictures with a digital camera.
Hey, I resent that.
Any other questions? I think we have time for a couple more. Janet?
So when I was doing some research about 40 years ago, I tried to get some of Austin Post's stunning photographs from Fairbanks. They were on big drums. And it was exorbitantly priced to attempt to have them open up, roll one, unroll one of these drums, reels, and get the photos. What do they have now? How did you access
So
these photos?
how I was able to access Austin Post photos, they're on the University of Washington's website. They're not, they're probably not the quality that you would have wanted, but they're there, and I was able to take from them, and they're free. They're public domain now. So yeah, he did some incredible photography, and it almost looks like space shots, some of these photos of glaciers, because they're so high up, 20 and 30,000 feet up. But right, so now you would find it much easier to access them than you did in the past.
And I couldn't use them, as I said, they were so expensive on these big drum rolls of film.
Right.
So they weren't going to cut them off or anything. So GSI, I think, in Fairbanks, Geophysical Institute.
Right. Yeah, I'll send you a link if you'd like.
Sure.
Any other questions? Sure.
Well, Austin Post indeed was a remarkable photographer. We have him to thank for the photos that he took after the 1967 landslide at Grunk Lake, where there was this terrific slide, and maybe half the material landed on the ice, which was kind of halfway in front of the slide, but the other half, went into the lake and created this, terrific wave that ran like 200 feet up the side of the mountain and scraped off the trees and washed them down the outwash plain into Ketchmack Bay, and they washed up with a spit and so forth, much to the Sawyer's delight and whatnot. But Austin Post's photos of that, and he got there several days after this, shows all these icebergs, distributed around the Grunk ice outwash plain, downstream from the lake. So you look at those photos, and yeah, there are all these little white things. Well, when you go and walk around that outwash plain today, you will see, pits, little holes like that. On a board, you get a hole in an outwash plain. Well, that's a block of ice that got parked there, when this huge flood went through. And we're talking about a flood that was like 20 feet deep, all the way across the outwash plain, which is like a mile wide, 20 feet deep, carrying these huge blocks of ice. Well, okay, there are the holes, and I have some pictures of Janet Klein standing beside, some of these holes, and some of them have more alders growing in them now because the water accumulates, so it's a little wetter place. But if you walk around that outwash plain and use your imagination, you'll see lots of these little kettles that were left behind. And Austin Post photographs this, shows that, yeah, those were blocks of ice, sitting there.
So, yeah, thank you so much for coming. And yeah, if we have time for one more question, if somebody has one, go ahead.
This is for the photographer, the Jim.
Jim,
The very first picture they showed of Greenwich Glacier, as it was, I would like to buy a copy of that. Pretty majestic.
The Gruig Glacier?
Yes, yeah.
Sure.
Sure. Yeah. Phone number I can call you, I'll come up and see you.
What was the date of that photograph, Jim?
What was the date?
More or less.
2002, 22?
I moved here in 2010.
Oh, it was
Came to
2010.
Homer, so probably 2015 or so. So, 10 years ago.
Well, a lot more of the big block in the middle,
Yeah.
as a matter of fact, is showing today than it is in your photo.
Yeah, you'll have to keep photographing it
Yeah.
across time.
Yeah.
Okay, well, thank you so much for coming. This is wonderful to hear.